Welcome, everyone. This is the third of our Adeva Insights sessions, this time with Viktor, who will be talking about building software at a large scale. Viktor is with us for over a year. He's been working at the Imagers team as a mobile consultant. So he picked up quite a few insights about working with large-scale softwares there, and also he had a startup that he needed to scale in the past. So he has a lot of background in the topic, and hopefully we'll all learn something from it. Viktor, go ahead.
Hello. Thank you everyone for joining. My name is Viktor and I'm a software engineer working at Adeva. And today I'll be talking about building software at large scale. In my past experience, I've been working on several projects that had a lot of concurrent users and high volumes of traffic. So certain scaling techniques were required in order to be implemented in order to have an efficient and well-performing platform. Let's start by what actually is software scalability. It's an attribute that describes the ability of a system to increase its capacity and functionality based on your user demands. We live in a fast-paced world where we want every information to be available instantly. So the software we're building needs to be fast and really responsive in order to provide that to our users. Nowadays, people have less than a second of patience. So if we're not really fast in our responses, no matter how good our idea is, people will eventually stop using it. There is one analysis done by Amazon, and they discovered that for every 100 milliseconds of latency on their platform, they lose about 1% of their sales. Huge margin, and we really need to think about it and what we're working to make it well performant so we have increase in our sales. There are two types of scaling. We have the vertical and the horizontal scaling. Vertical is pretty straightforward. We just upgrade our machine. We add more computing power, so we make it more powerful. We add more CPU, we add more RAM. There is advantages and disadvantages to both types. With vertical, as I said, it's pretty straightforward. If you have a physical machine, you just plug new hardware and you're pretty much good to go. If you're using some other solution, you just pay more money to have a better machine. The disadvantages, if you're using one machine, you have single point of failure, which I'll be talking a lot through my presentation, and the importance of not having a single point of failure, especially in large software. If you're having one machine, if that machine fails, practically your whole system is done. So you really need to take care of that. The other thing is there's limitation on the hardware you can add. You cannot just keep on adding unlimited hardware. And that is why we have horizontal scaling. Unlike the vertical scaling, horizontal scaling is not about upgrading your machine, but adding more machines to your pool. So you have the same machine just multiple times, and that's how the traffic is distributed along your available servers. This is, you can obviously add as much as machines you want, but it really increases the complexity of your development cycles. So you should really be careful on what scaling technique you to choose, whatever fits your product best. When to scale, really tough question. There's really no good answer for this. There are certain applications that don't even need to scale. It really depends on the product that you're building. There is no like a certain line, oh, now I have 1 million users, I need to scale. If you see increased latency, slow responses, then probably it's time to see what's going on and will some scaling technique improve the performance and lower the latency. Perfect example for this is Flappy Bird, and a game that most of us used or played. 50 million downloads, $5,000 revenue per day, huge number. and still this app had no need to scale at all. This was a local app, it was installed on your phone, so everything was running locally. There was no any interactions or traffic generated by the user. Everything was on your phone, so no matter these big numbers, there were no need to scale. Even that high score, that leaderboard was local, it was only just keeping track of your best scores and not comparing it to the other users. Today, I won't be talking about simple apps like Flappy Bird. We'll be talking a bit more complex platforms that needs to handle high traffic, have a lot of concurrent users, and require effort to maintain. This is Buzz. This is the project that we started 2014, 2015. I was the lead developer here. It was our own startup, started with two of my best friends. It was a social networking app that our target audience was high school and college students. The idea was to enable them to post and share their thoughts, but anonymously. Probably due to anonymity, it was a really huge hit, especially in Macedonia and other countries in the region like Croatia, Bosnia. As you can see, I was able to pull some old screenshots. We hit top charts on Google Play and also the iOS App Store. We were before above Viber and Messenger. So when we were doing marketing and expanding to new cities and countries, we had a huge inflation of users. So we obviously needed to change our architecture and work as smooth as possible with all that inflation from users. Unfortunately, our budget was not big enough, so we were not able to afford something like Amazon to do most of the scaling for us. So most of the stuff that we needed to do were from scratch. So I'm going to share my experience, what we did in order to handle that. We were working on so-called three-tier architecture. Most of us are familiar with this. Probably every software engineer worked on something similar. There's on the one side, it's the client. We had iOS and Android apps. We had a web version, but this was only for moderation purposes. There was the server, all the application logic lived there, and obviously the database where everything was stored. We were using Mongo database, but for your own purposes, you can use whatever you're most comfortable using. Bear in mind that each tier of architecture scales independently and differently. And in order to have a very well performant system, you need to scale everything properly and have this whole thing work good as a system. I'll be talking how to scale each of them individually. We'll start off with the database scaling. First thing, this is not connected to vertical or horizontal scaling, but please make sure you have efficient queries and proper indexes on your table. This will really improve your performances. You can have like 1,000 of servers, but if your queries are not performing well, you will obviously have slower responses. The next thing is the master-slave replication. It enables the data from one database server or the master to be replicated to one or more database servers. The master database server is the only server that's responsible for handling write requests, but the other so-called slave replications are there to serve reading of the data. This is really useful if you have a lot of read requests. Having a lot of replicated slaves will really improve the performance and allow you to do more read requests, but it also improves the write requests. And that is because instead of having one server now handling write and read requests, now we have one dedicated server for write requests. That is the first advantage. The other advantage is what I mentioned before, having one single point of failure. If this is configured properly, in case of a disaster and the master database failing, you will have one of the other replication to be assigned as the master database and serve the data to your application. In this case, if anything goes wrong, your users won't notice a thing because your database will continue working with a new master database. The next thing is a bit more complicated. It's called database sharding. Now, instead of having your data split into multiple database servers, you partition parts of your data across different servers. This is a bit more complex thing to do because the database, most of the database are not supporting by default. So you need to add a lot of development complexity to achieve that. And there is no certain rule how to split or how to partition your data. If you can, it's good to partition it by different modules or different tables that don't interact with each other. But if you have like a huge table of users, you will obviously need to break it down into smaller partitions. When you do this, you will obviously need to know how and where the data you're looking for is stored. So you will need some kind of a sharding key to know where to look for that data. One thing to bear in mind, when you're partitioning your data, you really need to be careful how you do that. You don't want to end up having one server containing like 80% of your partition and having another one just having the other 20%. You will try to split the data as equally as possible. I really don't recommend doing this unless you really need to scale it. In our case, we didn't need it. Master-slave replication was really good enough for us. But if you have more bigger app, this is the way to go. Server scaling. This is also pretty complex thing and probably a talk that can fit in its own talk by itself. But this is pretty much the representation or how we handled the requests. So there was like a pool of multiple servers, as you can see on the right side, that were in the load balance pool. And before them, there was a load balancer that was responsible for distributing the traffic among the servers. In a case where the server failed, like we can see the second server is failing, the load balancer knows about it and do not handle traffic to that server, but works with the other one that are online. This is pretty good approach. You can put as many app servers as you want, but still here we do have the single point of failure because the load balancer is also a server. It does not contain any application logic, but it can also fail, and we can have all the app servers working, but if the load balancer fails, we will have all our system down. We wanted to offer our users high availability and be online like 99% of the time. So we needed to iterate on this and improve this a little bit. And this is how we did it. We added another load balancer that was most of the time passive. And there was a health check pinging the primary load balancer. And in case something goes wrong with the primary load balancer, the secondary load balancer takes the responsibility and handles all the traffic among the available servers. This is how we lost that single point of failure. You can have multiple passive load balancer if you need. And also the app servers, it's really good to know that during high peak hours, it's really good to increase the number of servers, but in lower peak times, it's good to shut those servers down so you don't end up with a huge monthly bill and scale as you need, so you don't like keep on having servers and pay for them for no reasons. Another thing to consider about server scaling, if you have users that are all over the globe, and you want the request to be fast, you'll probably need to have servers in multiple locations across the globe. You don't want users from California to ping a server that's located somewhere in Germany. It's a long way for that request to travel. So if you really want that efficiency and want to serve worldwide, you should consider having servers on multiple places across the globe. What about the consumers? The client side is a little bit different than how the app server and the database scales. But keep in mind that the client side is the gateway on how your users are using the app, and it's where all of that traffic is coming from. So first thing you should consider is really try to reduce the number of requests you're doing from the client side. You don't want to make unnecessary calls to your app servers if you can cache them somehow on your client. Also, the client side scaling the client side is more about how your code is designed, and you really need to make sure your code is easy to maintain and add new features. When you're working on a large software, it's like a never-ending product. You always keep on adding stuff, design specification change. So you really need to consider that and be prepared for the stuff that you're building that will eventually change and be easy to do so. Obviously, you will need to break up large classes or large functions into smaller one, so you don't end up having this huge chunk of code that nobody even understands what it does. The code structure, we really want to avoid having code structure like on the left image, where everything is so tied together and you have no idea if you break something that's supposed to be totally unrelated to the stuff that you are working on. Breaking the code, like on the right picture, into multiple different modules allows even having a larger group of developers working on different things, and easy to merge that code together. It's pretty similar if you think about it, like how we handle the database and their server. We are splitting everything into smaller chunks of logic, so it's easier for us to work on them and maintain them. Some general tips. Code is easy to write but hard to read. And this is really true. When you're writing the code, you have all of your logic and all of the stuff that you want to write up in your head. And it's really to write them. You just translate them to the programming language you're writing. But when somebody else has read the code, they don't really know what's going on there. So you really need to make sure that it's really easy to read and everybody can understand it. A good tip for this is what I tend to do. Once I put a pull request, I go back to it either the other day or later that day to see what I wrote and maybe catch early some mistakes or even have another ideas or how can I improve the code. Dependencies and libraries. We all love them. We cannot live without them, obviously, but they're called dependencies for a reason. Once you integrate them in your project, you really depend on them. If they change, you will need to change. So be really careful on how you choose your libraries, and because you will need to stick with them. One bad situation that we had when we started the project, we used parser.com. It was a platform offered by Facebook. It's similar to Firebase. Practically, it was doing all the database and application server scaling for you. There was just an SDK you needed to integrate in your mobile apps, and you had your whole API service practically for free. This was great, but after a year, Facebook announced it will shut it down. And then we were left with users that were active, and we needed to make the migration not only for the users, but we needed to adjust on how Facebook were handling some stuff. So we really needed to make everything work and our users not noticing that we are migrating on a new architecture. This took us probably around a year. So instead of focusing on building cool features, we spent most of our time trying to make that migration. I'm all about moving fast and shipping features fast. It's good. It's the world we live in. But take a step back and refactor some stuff that you did. It's really important to not let your code be legacy and to refactor some stuff as you move forward. Testing, and I'm thinking about unit and integration testing. It's really good to have tests because it's kind of like a live documentation that it never gets old. Because if the unit tests fail, you're probably doing something wrong. Documentations, like written documentations, can get out of date, but tests cannot. If they fail, you're probably doing something wrong, and it makes things a lot easier when a new developer comes or you get back to a code after a while to see what's going on and have more confidence when you are changing some stuff that you're not breaking anything. And that's it. Thank you for your attention.
Thank you, Viktor. That was amazing presentation. If anyone has any questions, let's hear them. Viktor is open to answering. Maybe I should just stop the recording.